All right, we are going to go over the Part B-1 questions from the June 2022 Chemistry Regents Exam. Part B-1, you're still dealing with multiple choice. There's 20 multiple choice questions here, but no longer Part A, which is predominantly definitions and facts, a little bit with the reference tables, especially reference table S. Here, we're going to have calculations and more of the reference tables brought in. Let's take a look and start with question 31. Which electron configuration represents electrons of phosphorus in the excited state? Well, first of all, they don't give you the symbol for phosphorus. You have to either know what the symbol is or look it up on reference table S. Take the extra step. All right, phosphorus, it is element P. Now, you're dealing with the excited state, so you're dealing with a promotion of electron from a lower energy level to a higher. What you want to do is you want to go to the reference tables, go to the periodic table, find phosphorus, and you'll see the electron configuration in the ground state, and then you can compare. So let's do that. All right, so phosphorus, we have it right here. We have 2-8-5. That's phosphorus with the electrons in the ground state. Now let's go back and compare that to the choices. All right, well, 2-8-5 is phosphorus in the ground state, so it cannot be choice 1. 2-8-6, you got one more electron than you're supposed to, not phosphorus. 2-7-6, well, that adds up to 15, which is for an atom of phosphorus, and that is our answer, choice 3. And 2-7-4, there are not enough electrons. Again, choice 3 is our answer. Let's keep going. 32, you have 26.7 gram sample of which element has a volume of 3 cubic centimeters at room temperature? Well, mass divided by volume is density. So we're going to be looking for density here. We do need to calculate that. And then we can go ahead and match up our choices on reference table S. So again, reference table S is used quite a bit here. Let's do this. Okay, so we're looking for density here, which is the column all the way almost totally to the right. And we're looking for cadmium, chromium, I think, hold on, NB, which I can't pronounce the element, and nickel. All right, so let's take a look here. Chromium, I see it. It is 7.15. I calculated a density of 8.9. No match there. We'll keep going here. So that's chromium. We got to find the other 3. Okay, just going down. The next one is nickel. And look at that, 8.90. That exactly matches the density. I don't really have to go any further, but I'll show you the other 2 anyway. Okay, NB and CD are pretty close. They're almost 8.9s, but they're not 8.9s exact. So now we know the answer. So for 32, the answer was choice 4. All right, the next question is asking about a nonmetal and nonmetal being a solid. I'm starting with the periodic table. Again, if you don't know just by looking at the choices what the answer is, please come to the periodic table. Now, the left-hand side of the table, of course, these are all our metals. And to the right of what I call the staircase here, we have our nonmetals. On the staircase, there are 6 elements that are known as the semi-metals or metalloids. Make sure you know them, memorize them, or at least memorize their location here. There are also a bunch of elements that are gases at room temperature. That, of course, is hydrogen and helium. neon, oxygen, and then your halogens, fluorine, chlorine, bromine, and iodine. Oh, I'm wrong. Bromine is not a gas at room temperature. Bromine and mercury are your liquid elements, the only two liquid elements on the periodic table. All right, let's go back to the question. So for question 33, which element is a nonmetal and a solid at standard temperature and pressure? Lead is a metal. Nitrogen, oh, wait a minute, that is a nonmetal, but the problem is nitrogen is a gas. Sodium is a metal. Your only answer here is sulfur. If you want to double check the location on the periodic table, go for it. All right, for 34, what is the molecular formula for? Well, obviously you have an organic compound here. A molecular formula is just your atom inventory. It's the number of carbons, in this case, hydrogens and oxygens, so you're literally just going to count them up. You have 1, 2, 3, 4 carbons, so it can't be choices 1 and 2. So now you're left with 3 and 4. I guarantee you, since both of them have 8 hydrogens, 3 plus 2 is 5, plus 3 is 8. The key is there's 2 oxygens here, so the answer is choice 4. For 35, a substance conducts electricity in the liquid phase but not in the solid phase. This substance can be classified as. Here we're dealing with a definition. Again, remember your definitions and your facts you have to know. Very important. And we are dealing with an ionic compound that are known as your salts, right? They are together in a crystalline lattice as a solid, but you liquefy them or you dissolve them in water and the ions break apart. That's 35. For question 36 now, we are looking at percent error. For percent error, there is an equation on reference table T. Let me show you where that is. All right, reference table T, right here. Don't confuse percent error with percent composition. Two different things, and look at the equations. They look a little bit different. Measured value is the student value, the experimental value. The accepted value is the true value, the known value. Or maybe you have to look it up on reference table S. Let's go back. Sure enough, we do need to go to reference table S, so let's do this. We'll go back to the question. We're looking for gallium. We're looking for the melting point. This would be, again, the accepted value, true value, known value of 303. We need to plug that in. Okay, the student value is 309. It is the measured value, which is 309 minus 303, which is the accepted value, divided by the accepted value, 303 times 100, and that makes the answer here choice 1. All right, 37, which chemical bond is most polar? If you want to figure out the most polar bond, it's going to have the greatest electronegativity difference between the different atoms that make up a bond. Now, that again is on reference table S. What happens is, though oxygen, sulfur, selenium, tellurium are all on the same, or they're all in the same group or column on the periodic table, from most electronegative down to least. So we know that oxygen and hydrogen are going to have a more polar bond than the other three because of that trend. And we also know water has special properties because the attractions between water molecules is very strong and known as hydrogen bonding. So our answer here is choice 1. Let's move on for 38. What is the amount of heat required to melt 43 grams of solid magnesium oxide at its melting point? Now, because we're given magnesium oxide and not water, we're not going to look for the heat of fusion constant on reference table B. But we do need the equation. And again, that's on reference table T. If you go down reference table T, we're looking for Q is equal to M, and then this is melting, so that is heat of fusion, so times HF. Now, All you're doing then is multiplying 43 by 1.9 times 10 to the third. And you'll notice your four answers are given to you in scientific notation. Students would have more of a problem, I think, with that than anything else. So if you have a scientific calculator and you know how to use it, just plug it in. If you don't know how to use it, then what you're going to do is you're going to take just a regular calculator, take 43 and multiply it by this number in front, 1.9. That gives you 82, but 82 times 10 to the third would be equal to 8.2 times 10 to the fourth. We're just sliding the decimal over one decimal point or decimal place. 39, hopefully you recognize this right away. This is what's called a distillation apparatus. You've seen pictures, maybe you've seen it in person in the lab, and this, of course, can separate two different liquids by boiling point or something dissolved in water to boil the water. Alrighty. For 40 here, we are back to the heat equations. In this case, we're dealing with solid aluminum. We have a specific heat capacity. This is Q is equal to M C delta T. Reference table T lists this one as well. We're given a mass of 24 grams for the aluminum. We're given the constant as 0.9, and our delta T is 350 minus 300, or 50. All you're going to do, of course, is multiply these together. So 24 times 0.9 times 50, and we get an answer of, rounding to 2 sig figs, of 1100, which is choice 3. For 41, we got to go to reference table G. Which solute sample in 100 grams of water at 40 degrees Celsius can produce a solution equilibrium in a closed system? Equilibrium in a closed system means a saturated solution. Reference table G is your solubility curves. In other words, which one is going to be on the line or the curve for that solute. So let's go do that. So what you see here is I've drawn the lines for the four choices. I was going to make them in different colors, and then I forgot. But the only one that is above the line or on the line or above the line is for KCl. So all that means is there's excess KCl sitting at the bottom, which makes it saturated, which means it's in equilibrium. So we're talking about choice 3. Question 42. We have an equation in equilibrium, and you're asked which change favors the forward reaction. Remember, your forward reaction is from left to right, reversed is from right to left. So we're looking at the forward reaction here, and which change favors it. So number one, increasing the concentration of O2. If you add to one side, the shift is away from the side. That actually should be our answer, choice 1. Let's check the others. Increasing temperature would be adding energy, and that would mean this side would go up and it would go back the other way or reverse. So that's why choice 2 is not the answer. For choice 3, hold on, let me get rid of this. Decreasing the pressure. When you're looking at pressure for a system at equilibrium, you're going to look at total moles of gas. Don't worry about solids and liquids. I have 2 here and 1 for a total of 3, and I have 2 on this side. So if I decrease the pressure, that favors more moles of gas. So again, it's going to go the reverse direction, not what we wanted. And then decreasing SO2, when you remove, it's going to go towards or take towards TT. So it's T, T. Add, the shift is away. You take, the shift is towards. Again, 2, 3, and 4 here are in the wrong direction. The only answer it could be is choice 1. Moving on, when ice H2O melts at 0 degrees Celsius, entropy increases because. All right, so in 43, you're going from a solid to a liquid. And what happens is you have more arrangement or not more arrangement, you have more disorder or more possibilities as far as the water molecules moving around. And that's exactly what entropy is about. It's about randomness. So in this case, then the choice would be 3. Average kinetic energy, remember, that has to do with temperature. It's our definition of temperature in chemistry. For question 44, you have propanol and propanone. They definitely have different chemical properties. You'll notice the endings of the words are entirely different. The beginning of the words, of course, is the same. Prop is a prefix for 3 carbon. So these are both 3 carbon molecules, but an Al ending tells me I have an aldehyde, and an One ending tells me I have a ketone. And as a result of that, we say that the function of those C double bonds O on the molecule being in different places is going to change the chemical properties, which are known as functional groups. Now, there is a whole reference table on this. Reference table are your functional groups, and here is your aldehyde and your ketone, the Al ending and the One ending. So you can play the matching game here. Remember also there are 2 other organic reference tables. Reference table P, which are those prefixes to tell you the number of carbon atoms in the molecule. Reference table Q, these are for hydrocarbons, meaning carbon and hydrogen atoms only. And then, yes, once again, we have reference table R, which is our functional group table. In other words, besides carbons and hydrogens, other elements that could be on an organic molecule. Okay, speaking of organic, let's look at 45. Here we have the structural formula of a compound, and you're asked what's the name. When you name organic compounds, the first thing you want to do is look for the longest carbon chain. In other words, it could be these carbons straight across, of which there are 6, or I could go straight and then up, but that's only 5, or I could go straight across and down, and we're back to 6. So either way, we're talking about a 6 carbon chain as the longest chain, and 6, when you go back and look at the reference tables, is for hex or hexane. They're all single bonds, so that's why it would have an ane ending. Alrighty, so we can knock out octane. And now, since this is my longest chain, I have these 2 side chains of 1 carbon and 3 hydrogens, which is known as a methyl group. They are not on the same carbon. They're on 2 different carbons. And the way that we recognize them, yes, they're dimethyl, but I also need to count the longest chain, and where the numbers are the lowest is the way that we're going to name this. In other words, I could count from, in fact, let me change this for a minute. Let's say we do, that doesn't work. Let's do something darker. How about that? 1, 2, 3, 4, 5, 6 as my longest chain. So I'd have a methyl group on the 4 and the 5, or I can go ahead and number it from right to left and have 1, 2, 3, 4, 5, 6. And that means now I have a methyl group on the 2nd and the 3rd carbon. You always go with the lowest numbers. So that knocks out choice 4. It's got to be choice 2. Looking at question 46, we're still dealing with organic chemistry. And now what we're looking for is the classification of this compound. Well, it's not just hydrocarbons. There's carbons, hydrogens, there's an oxygen and a nitrogen. So what that means is I need to go to that reference table with the functional groups and play the matching game. What molecules contain oxygen and nitrogen? So let's do that. For an oxygen and a nitrogen to be on a molecule, we got to go down all the way to the bottom of the reference table, and here it is, right here. This is known as an amide. So that's the functional group, and that you would use as your answer. All right, so 46 was choice 1. For 47, which substance is an electrolyte? Remember, electrolytes are ions in water. And what substances produce ions in water? You got your acids, you got your bases, and you have your salts. Those are the three, right? First of all, 3 and 4 are hydrocarbons. Typically, even if you have sugars and alcohols that dissolve in water, they do not split apart into ions. They are actually known as non-electrolytes. Cross those out. Hydrogen alone is a gas. That's not going to produce ions. The only choice here is choice 2. But remember, there is a table that has a group of common acids on it, and there's another table group of common bases. You can certainly go to that and play the matching game, and you'll see HCl is hydrochloric acid, a common acid. Also, your salts, you have metal and a nonmetal, or metal and nonmetals. All right, so it should be easy to recognize. For 48 now, an indicator that is added to an aqueous solution with a pH value of 5.6, which indicator is paired with its observed color in this solution? Methyl orange, phenolphthalein, brome chrysol green, or thymol blue. All right, so we got to go through the reference tables for sure on this and take a look. Okay, so we need to match the color of the indicator at a pH of 5.6. Methyl orange is supposed to be yellow, and at 5.6 that makes sense to me because you can see by looking at methyl orange, 5.6 is higher than that transition, right, from red to yellow. So 5.6 is higher than 5.4, which would make it yellow. I think that's our answer. Let's go through the others. Phenolphthalein with a pH of 5.6, that's obviously less than 8. The solution would be colorless, but the choice said pink. That's wrong. Brome chrysol green at 5.6, it should be a blue color because that's higher than 5.4. So that's not our answer. And then thymol blue. Thymol blue at 5.6 is going to be here to the left or lower than 8.0 and would be a yellow color. So the only one that matches, methyl orange, that's our answer. Methyl orange, choice 1. All right, we have 2 more left in this section. Remember, for part A and part B-1, it's a total of 50 multiple choice questions, and you want to score as high as you can on these parts. You need at least 50 points out of the total of 85 points to earn a 65, typically on a Chemistry Regents exam. So practicing these questions, and not just part A, folks, but this part here is going to be extremely important. All right, for 49, we have a pH value of 2 for solution A. Solution B is 4, and you're asked how many times greater is the hydronium ion concentration in solution A than in solution B. Well, one of the things you always want to keep in mind, as the pH gets lower, the hydronium ion, which is the same as an H plus and H2O, the hydrogen ion, which makes an acid because you have excess hydrogen ions in solution compared to hydroxide ions. Anyway, it makes it more acidic. So solution A, 2.0, solution B, 4.0. All right, with every move of the pH scale down, that increases the hydronium ion concentration by a factor of 10. So 4 to 3 would be 10 times. 3 to 2 would be another 10 times. 10 times 10 is 100, and that's our answer. All right, finally for 50, which net change occurs in both nuclear fission and nuclear fusion. All right, and that is a tiny bit of mass, and each one of these reactions is converted into energy. That is choice 1. That is a fact, Jack. That ends again B-1. Keep working hard and good luck.